I'm now going to be taking a bit of a look at file formats. This is not something which is specifically necessary at the moment, and I don't really need to do that for what I'm doing with Unity and Houdini. This, however, is something which you should pay attention to. You should always be aware of which formats and project structures you can use, as there's always a possibility of losing every single thing which you have within your project. In this case, I'm not just referring to the loss of data or potential drive or machine failure. Instead, I'm referring to the fact that you are almost always using somebody else's tool. And when you're working with software which is made by somebody else, you should always make the assumption that that software could disappear the next day. And this actually applies as much to open source software as it does to proprietary software. Any software can have legal changes made to it, whether through the company itself or externally. I will not try to go over this because it is a reasonably complex topic, but the basic point is you should always assume that the software which you have and the software which you're using may not be available tomorrow. This may sound dramatic, but it has happened in the past. For example, in the month which I'm making this video, which is December 2024, Modo is being discontinued. With this in mind, all of the work which you do is at some point going to be saved in files. These files will either be used for transfer or preservation, as well as for interchange. Currently for this project, the main software which I'm using is Houdini and Unity, and the main file format which I'm using for transfer is FBX. I will not be discussing FBX in any detail. FBX is straightforward. It is also closed source and proprietary. By default, FBX is also not a readable format. The other main format of transfer which I'm using is Houdini Engine. This is a fantastic tool and it's great for integration between projects, but it's not particularly useful for longer term interchange and is fundamentally best for prototyping, where after you've created the basic setup, you convert that into native formats. I will also not discuss the Geo format, which is Houdini's native format, even though that can be used in concert with Houdini Engine. There are file formats which I will need to use in the future, as they are relevant for features that I do want to use. For example, I do want to work with strand-based hair. To do this, I'll need to use Alembic, and this will apply if I was using Unreal as well as Unity. Alembic is also something that we will want to use if we're transferring simulations. So Alembic is the first extra format which I'm going to use. Alembic is a reasonably straightforward file format. It is a simple export and import format, which is a single file format, and I don't really need to go into it in detail. The main use for Alembic is to export mesh animations, especially animations where the mesh changes per frame, and I'll primarily be using it in the case of simulations. The first format that I'm really going to look at will be glTF. This format is released by Kronos Group, and the name stands for Graphics Library Transmission Format. glTF is in many ways the closest competition for FBX as a character export format. glTF actually has some major issues in terms of use with Houdini. These are issues which I can personally work around and shouldn't be too much of a problem, but I would not expect this for most people who are using Houdini, as these will be extremely technical workarounds. These issues are actually not related to export, so export will be fine. There are, however, some very major limitations when it comes to importing glTF files, and we'll need to look at that. The next format is actually not a file format, and that would be USD. USD will often be referred to as if it is a file format. However, it is not. It is actually a project structure. The main purpose of USD is not actually as an interchange format. The main purpose of USD is to manage projects. This means that USD does not work off individual files. It also doesn't work off just a couple of files. Instead, it is a folder structure which accesses multiple files throughout a number of folders. So you're not building a single item with a single file. You're building a scene, and that scene is part of a larger project. And that project will be dealing with multiple files of multiple formats. There are some issues which I have with USD, and I find restricting about it. These are rather minor, but they result from the fact that USD is Pixar's project structure. It is built to work specifically with Pixar's workflow, and when you're using it, you tie yourself into that workflow. And there are a lot of things which are very specific to how USD works, which are different to most of the applications which you'll use USD with. This is not necessarily an issue, but when you use USD, you are tying yourself into somebody else's workflow. That said, there are a number of advantages to USD, and there are a number of reasons why you should consider basing your project based off USD as a project format. So I'm going to be looking at USD. I'm also going to be looking at glTF. I may not automatically use these initially, but these are formats which we should consider using, as they do have a number of advantages in terms of retaining information and accessing information. Of the three of these formats, there's only one which is officially supported by Unity, and that will be Alembic. glTF does have complete support, but the package is not officially distributed yet, and USD is still in the experimental stage. In Unity, all of these formats will need to be installed via the package manager, but Alembic is the only one which is going to be available by default, and I'm going to install that within the project now. The next format that I'm going to look at is glTF, and we can search for glTF and it will not show up within the package manager. The glTF plugin does exist, and it is actually not in experimental status, so it is actually a complete plugin, but it is not listed in Unity by default. We can search for the documentation online and we will find it. This plugin is called glTFast. Here you can see that this should support 100% of the glTF specification. glTF is designed as a real-time format, so it's not just supposed to be an interchange format. Instead, it can be used directly within a real-time application as the primary source of data. This is not something which FBX does. FBX is purely an interchange format. To find the information about how to use glTF in Unity, we'll need to look at the More Information page, and here we'll look at the Upgrade Guide section. Here, under the Transition to glTFast, we'll get the correct information as to how to install glTF. In this case, there is a Git URL which is com.unity.cloud.gltfast. I can return to Unity to install this. Here I'll press the plus button, and I'll select the option Install Package from Git URL, and I can paste the line which I've copied over here. So now I should be able to import glTF files. Generally with glTF, we'll be using this for geometry or we'll be using it for character animation. In many ways, glTF is the alternative to FBX, and in my case, I'll primarily be using this as an animation format. glTF is a broader specification than FBX. It does handle larger scenes and materials more efficiently than FBX does. As stated earlier, I would mainly use glTF for animation, and there are a couple of things which we want to know when using this format for animation. glTF supports two main file configurations. The default distribution of a glTF file will contain two files. It can also be distributed as a single file, although I would not actually recommend this. When we distribute this as two files, the first file will have a glTF extension. This is a human-readable file and is essentially a JSON file. We'll use this file to identify what information is within the glTF files. The second information will be a binary file. The extension for this file is an abbreviation of binary and will be bin. The glTF essentially provides a map for the information within the binary file. These can be combined into a glb file. When we do this, however, we will no longer have a human-readable file, so it will not be possible to identify what information is in this file easily. Technically, a glb file is not completely unreadable, but I will not currently be using this format. For animation, there are some things which we should know about glTF. The first is that it supports 4 weights per vertex. So essentially, for each vertex, for every triangle within our mesh, we'll have a vector which will have 4 values. Each of these values will represent a weight for an individual bone. This needs to be a normalized vector, so this vector should essentially have a maximum length of 1. These values should normally be represented as a float. There should also be a second vector representing these joints, and this vector is going to represent the bones. So each of the numbers within the vector should essentially be an ID for your joint. The bone numbers will be represented as an unsigned short. This is a 16-bit integer, and will have a value which will range from 0 to 65,535. This will represent the amount of bones which we can represent within this file. We should, however, subtract 1 from this value, as we should assume that the last value will be used as a marker, and that certain applications will not use this for the bone, but will instead use it to represent a wraparound for this integer. So the number of bones should never be a problem within this file format, but we do want to make sure that our weights are normalized and that we have no more than 4 weights per vertex. We also should know that glTF will support blend shapes, although glTF will use the term morph targets. There's no specific maximum limitation as to how many morph targets can be supported. There is, however, a minimum requirement, where all applications that support glTF should support at least 8 morph targets, which means that you should be able to guarantee support for at least 8 morph targets on a mesh. So now I'm going to take a look at glTF within Houdini. glTF is actually reasonably simple to export from Houdini. However, we only really will be exporting it from a SOP context, and essentially we have 2 nodes which we can use to export glTF. To get a better idea of what we can actually do with glTF, we should look at the help. Here we'll have the table which will explain the export and import capabilities. All of these represent SOP nodes, apart from the final option, which is the glTF hierarchy. This is the main object level node for glTF and is used for import. We'll not be dealing with this, we'll only be looking at glTF as an export format for the moment. So basic export and import of scenes should be fine, and we should have no problems importing or exporting the mesh. We will, however, begin to face issues when we're trying to import materials. We'll not be able to import glTF textures correctly. We'll also not be able to import cameras. These of course are inconveniences, but they're not major issues. The real issue here is that we cannot import skinned animation. We can also not import animation in general. So this is what I mean when I say that glTF is useful for an export format and not for an import format. One of the main reasons for using glTF is that the format is open, but it's also very easy to set up in custom software. I currently have my own engine which I'm working on, which is primarily experimental, and is to help me improve my understanding of graphics APIs. And while it is unlikely that I'll ever manage to reach the point where I can develop things with it, I do still want to be able to use files which I'm developing in this part of the project in that project as well. I can now set up a basic export within Houdini. I'll enter the geometry node, and here we'll have two SOPs for export. These will be the ROP glTF output. This node is for basic mesh and scene output. This will not export any animation. I'm then going to get my glTF character output. This node is very similar in terms of its setup to the FBX character output node. This is going to be one of our most basic possible tests, so we're going to be exporting a box. We'll set up this box as a character, so I'll get a skeleton node. This box can now have a skeleton which will contain a couple of bones. I could of course rename these joints, but for the moment I'll leave these as points 0, 1 and 2. I'll need to weight my box based off the skeleton, and for this I'll use a joint capture by harmonic node. This will be required for the glTF character export. For the standard glTF export, we can connect our geometry directly to the ROP node. This will have slight issues and it will give us warnings, but we can test the basic export now. I'll specify a folder here. I'll call this folder glTF. Here we're going to be exporting this as a glTF file. Houdini will also allow us to export this as a glb file, but as stated previously, that actually makes the file opaque, which loses the number one reason to use glTF. I'll call this file box, but I'll give it a prefix of mesh so that it's descriptive. I'll then need to specify the extension, and this will be .gltf. I can export this, and this does export successfully, but it does give me a warning. This is not something which will break the export or stop it working, but this does mean that we are actually not exporting enough information for the specification, and that there is required information that this geometry does not have. The issue in this case is that this mesh does not actually have UVs. This isn't an issue for SPX, but for glTF we will always want to add some basic UVs to a mesh before exporting it, and I'll do this with the UV unwrap node. Once again, this is not required, but it is recommended to have UVs as part of the format. I should now be able to look at the files which I've generated. In my glTF folder I have two files. The first is called meshbox.gltf and the second is meshboxdata.bin. So the biggest advantage of keeping these files separate, and the biggest advantage of using glTF over FBX, is that we can examine the structure of our file and we can see what data is in the file by opening the glTF file. Essentially this file is a JSON file, so we can format this as a JSON file. There are two main sections of glTF which you need to pay attention to. The first is the accesses. This will be followed by buffers and buffer views. These are sections I'd generally ignore. These will mainly be used if you're trying to write the parser for the binary file. So this contains information about where things are in the binary file. It doesn't contain basic information about what the geometry is. This will be followed by nodes and meshes. This will contain the definitions of what is within the scene. It will not contain the specific information, but it will tell us what types of information there are and how that information is stored. The node will give us general information about what meshes we have. It will also give us information for things like cameras and joints. This is the basic description of the meshes and the joints. It will not contain major details about these. Essentially, the nodes are used to organize the scene. This isn't a particularly good explanation, but this is a basic overview in any case. So after the nodes, we'll have our mesh. The mesh will give us information about what is actually contained within the mesh. For example, the mesh will contain attributes. In this case, we'll have the texture coordinates, which will be stored in our UVs. We'll have tangents for the mesh. We'll also have the point positions, and we'll have the normals. This is also where we can store any custom attributes. If we should be able to use custom attributes but cannot get them to work, this is where we can see how the custom attributes are being stored. So we could add custom attributes within Houdini, but the names may be changed slightly here, and this is where we'll be able to see what attributes are being exported. These attributes all reference a number, and the number corresponds with the accessor. These are the accessors which I mentioned at the start of the script. So our texture coordinates reference accessor 4. So here we would have buffer view number 4, and this would match up with our texture coordinates. This will have a component type which will specify what type of information this is. For example, if this is an integer or a float. These use codes which are specific to glTF, and you actually need to look these up within the specification. This will be followed by the amount of items of this type within the mesh. It will also have the type of data which is stored. So in this case, 5216 is a float, and this is a 2D vector containing 2 floats. This will be followed by 2 values. These represent the first value of this data type and the last value of this data type. This will allow you to easily manually confirm whether you're getting the correct information from the buffer, as it should give you the UV information for the first vertex of this mesh and the UV information for the final vertex of this mesh. So if we're having issues with this, we can always check the data manually within Houdini to test to see whether the mesh information is being exported correctly. This is also useful when you have to write the file importer yourself. So essentially we can tell what information should be within this file by looking at the attributes and looking at the accessors for these attributes. After the primitives within the mesh, we'll see that we have a name. This name is currently being defined by the node which is connected to the ROP node. This is the default behavior for glTF. We can update this to work with attributes instead. I'll do this by using the mesh name source parameter, and I'll set this to work with an attribute. This is going to be a primitive attribute, and by default this will be name. I will not really change this, as this is actually consistent with the defaults for FBX, and keeping this the same will make it easier to export both file types at the same time. So to fix this, I'll get a name node and I'll attach this after the box. The name will be a primitive attribute, and for the moment I'll call this box. I can now export the file again, and when we look at the updated file, we'll see that the mesh now has the name box. So that's how we'd export a basic mesh. Although in my case I will only be using glTF to export characters, as I will only use this for animation. Because of this, I will need to test some basic character export options. So I'll connect my mesh and my skeleton to the joint capture by harmonic node, and I'll connect this into my character ROP node. I will need to specify the file that we're exporting, and in this case I'm going to call this char box. In order to export this, we'll also need to give information for our animation, and this will be done using the configure clip info node. With glTF, we should only ever be exporting a single animation clip at a time, although we could argue that this is generally good practice in any case, as it does make it easy to identify what is in a specific file. I'm going to call this clip default, and I'll activate all of the options on the configure clip info node. I can then press the save to disk button to export my file. We should now be able to examine this file as well. The biggest change we'll see with the character export is that we now have far more nodes, and these should represent our skeleton. All of these essentially contain a transform and a name. These are the joints within our skeleton, and we named these joint 0, joint 1, joint 2, joint 3, and joint 4. These are the default names which we use within Houdini, and they're used here as well. I did not clear out any of the attributes, and this means that we do now have a custom attribute, and this attribute is pcapped frame. So if I want to be able to use this value within a custom engine, I can do it. It should also be possible to use this attribute within engines like Unreal and Unity. So that will give me my file, and now I want to be able to test if I can use this within Unity. Here I'll want to add a folder for the inputs, and I'll name this glTF. I can then drag and drop my files onto the Unity interface, and I'll need both the glTF file and the data file. The glTF files do have an updated icon, which is good, which means that they are probably being registered correctly. I can drag one of these files into the scene. In this case, I'll drag the character box. This should give us the box, and it should also give us a hierarchy of joints. The hierarchy will only be visible within the hierarchy view. It will not be visible within the project view. I should of course be able to manipulate these joints. So if I select my joints, I should be able to rotate it in the viewport, and the mesh should deform correctly. So that's my glTF export. glTF is the alternative to FBX. It's a far more open format, but it does have a lot more limitations in terms of import. The biggest advantage for glTF is with my test engine, where importing glTF is actually far more straightforward than importing FBX, as the information in the glTF files is far more accessible. We can now look at our next input option, which will be USD. To work on this, I'll return to the package manager. And here I'll search for USD, and this once again will not show up. USD is available as a package, but this is an experimental package. This is a far less mature package than the glTF package. As with glTF, we should be able to find the documentation for this package by searching for it on the internet. And once again, we'll be installing this with a git URL. In this case, this will be under com unity formats USD. I'll copy this and I'll return to Unity. I'll click on the plus icon and I'll select install package via git URL. And I'll use the URL that I've just copied. So as I've stated previously, USD is not really a file format. It's far more of a project format. The other thing to note is that USD is not meant for animation, and especially not skeletal animation. There are some minor skeletal features within USD, but they are not meant to be an animation transfer system, and animation is considered to be beyond the scope of USD. So USD will not be an FBX replacement, and if you try to use USD as an animation format, you will fail because it is not meant to do that. And animation features will probably not be added to USD at any time soon. So I now have USD installed, and we should note that unlike glTF, we have an explicit warning that this is an experimental package. While we did need to install glTFast explicitly, it is not actually marked with an experimental package, and it can be treated as full release software. We should, however, note that your USD support is still experimental. USD will also work very differently from other import options within Unity. Generally, with other options, we can drag and drop things onto the interface. USD, however, has a specific drop-down menu for import options, and these are explicit import options. So here we'll have import options for USD. We will also have export options. One of the things which I would like to be able to do is to use Houdini as my main editor. In other words, I would like to be able to edit my scenes within Houdini and not necessarily focus on having the scene editing done in Unity. Theoretically, I can use USD to help do this. We can also theoretically do this with the Houdini engine using session sync. But using USD for this will be slightly more explicit as we are using project files. In either case, it should allow me to customize my workflow more. For the moment, I'm not going to go into any detail in USD. I'm just going to set up my most basic export, and we can take a look at this setup. USD is an extremely broad topic, and it covers a lot of features within Houdini. I could not hope to cover it in anything this short. So I can begin looking at USD more when I actually begin setting up levels, and start to work on more interactive geometry and test geometry. So in this case, I'm just going to get a geometry node, and I'm going to add a box. Essentially the same basic export that I did with glTF. We'll define our USD project within its own context within Houdini, and this will be defined within a LOPS network. Within the LOPS network, we'll want to reference our geometry, and to do this, I'll use a SOP import node. I'll define the object path for my box by referencing the geometry node. To export this, I'll need a ROP USD node. I can connect my box to this to export it. I can then specify a folder to export this to. For the moment, I'll specify this within my project directory under a directory USD. And over here, I will not be exporting as USD. USD has three formats. They are USD, USDA, and USDC. USDC is a compiled format and will not be readable. USDA is an ASCII format and is going to be readable. The standard USD file, however, can be either, and we can convert it between one or the other. However, initially I want to be able to read my files, so I'm going to explicitly state that I want these to be ASCII files with USDA. So the name of this file will be test scene, and it will be a USDA file. So I can accept, and this will set my save path. I will, however, have warnings on my SOP input file, and when I try to export my file, I will get an error. The problem which we have here is something which I've already mentioned. With USD, we're not creating a single file, instead we're creating a project. And we'll need to specify a save location for each item within this project. We should always remember that USD is not designed to be a file format. Instead, it's more of an asset management system which will allow teams to collaborate with each other. And this can be done using multiple applications which will all be using the same data. Because of this, we're not working on a single file. Instead, we're specifying every single file within this project explicitly, and each file will need to have its own save location. The box is a specific piece of geometry, and this will be saved as a specific item, so we'll need to specify a path within the USD project where we are saving this. If we look at the SOP import, we'll see that there are a multitude of options to control this kind of information. as most of the options here are not actually related to the SOP file itself. Instead, they're focused on how we integrate this within the project. What we need to do here, however, is reasonably simple. We need to specify a save path for this box, and this will be called a layer. To specify the path, we'll activate layer save path, and I can now specify where within my folder we are going to save this file. Here I'll create a new folder and I'll call this geometry. In this geometry folder, I'll specify a file name for my box, and this will be box.usda. I can now save my file, and this should export correctly. We should now be able to look at the updated files. I should be able to look at my exported files, so I can go to my project, and here we should have a USD folder. Within this folder we should have a test scene USD file. We should also have our geometry folder, and here we should have our box USD file. I can open the box file and we should be able to see this as a text file. The syntax here is very similar to Python, however it is not Python. Within this file we should see that we have information about our box, and we should see that we have all of the information about the geometry here. So we have the extents, which are essentially the bounding box information. We have vertex counts as well as indices. We also have all of the point positions here. So essentially here, this file is defining our box. We will also have the test USD, which is our scene USD. This file should contain all of the information pertaining to the general project, and essentially what we currently specify in here is within sublayers, and this is specifying the folder where we will find the box. So essentially our ROP-USD node is exporting the main file for the project, and this file is primarily referencing other files, which will give the information for the project itself. I now want to use this within Unity, and for this I'm going to copy the path for this folder. We'll then import these files using the USD dropdown, and here I'll select Import as Game Object. I'll specify my USD folder, and then I'm going to import the test scene. I've managed to import this as part of my glTF hierarchy. I'll separate this to be part of my main hierarchy. This game object is called SOP import. This is of course a naming issue which we'll want to change eventually, but I'm not going to be doing this at the moment. In the scene we can see that we are actually bringing in the box. This USD asset is being brought in as two game objects, and the first is being used to define our USD scene. There are a number of options here which I will not go through at the moment. The main option to look at here though is the download payload option. With USD we'll usually define our meshes and cameras and lights as payloads, in which case we'll need to use this option in order to update the scene. As I said previously, I will not go through any of this now, as this would require its own video. However, for the moment our USD is working. When we bring in our USD, it creates a USD game object, and the USD structure will be constructed beneath this game object. And we should note that this will not always bring in the entirety of the project, as we may need to load payloads explicitly. So this covers some of my options in terms of exporting and importing files. Both USD and glTF offer the advantage that they are readable formats, and because of this, it is always possible to use these files to bring information into any application we want to, as long as we have the ability to modify that application or create an importer within that application. In my case, the main reason for looking at these file formats is to use them within my own test engine, but using readable file formats which are open is also a good idea, as this provides far more flexibility in terms of things like backups.